Hello and welcome back. We are going to start a series of videos explaining different data structures. And the first in the series is arrays. So, arrays are the most basic yet widely used data structure, and it's mainly used to store a list of items. And the items can be of any data type, like numbers, strings, characters, or even another array. And it is also called as linear data structure. That is because it is used to store the data in a sequential manner, one after the other. So, in general, arrays are represented with a rectangular box which is separated into different sections, and each section holds an item, and each section is given a number starting from 0. This is called as the index number. And the index is used to reference the section or an item directly without going through the entire list. If you know that your item is stored in index position 3, then you can reference the item directly by using array of 3. And the other important thing about arrays is not only stored sequentially, but also it's stored consecutively. The difference between sequential and consecutive is that sequential just takes care of the order of the elements, but when we say it is consecutive, that means it's right after one another. Consider this as our memory board, where each square represents a byte in the memory. So let's say we are trying to store this array in our memory block. So your processor will start with the first free block. So let's say your first element, that is your zeroth element, is put in the first block, and then your first element will be put here. However, imagine that the next box is taken up by some other processor. Then what happens is your third element or your element at index 2 cannot go right here because this breaks the consecutiveness. So what happens in this case is these elements are reordered and they are moved to a different location here. So where you have four consecutive blocks. So this will become your new zeroth element, and then first element, then the second element, third element. So this is what we mean by consecutive memory allocation. This is all taken care by the processor for you, but it is something to be aware of. This will have some impacts on your memory fragmentation as well as the time spent in rearranging the elements. So this is how memory is allocated for arrays. And moving on, there are two types of arrays. One is static and the other one is dynamic arrays. And both static and dynamic arrays allows the same set of operations to be performed. But the main difference is that the static arrays have fixed memory, whereas the dynamic arrays has runtime memory allocation. So when we say runtime allocation, dynamic arrays allocates memory as the array gets filled up. So it starts with just one block where you insert the initial element. And then when you try to add a new element, it just doubles its size. So since it is just one element here, it doubles and becomes two elements. And then when you try to add the third element, it doubles itself and becomes four elements. And when you try to add the fourth element, it doesn't do anything because you already have the space for the fourth element. And when you add the fifth element, it doubles itself and becomes eight elements. So every time you run out of the memory allocation and try to add a new element, instead of just adding one memory block, it just doubles the size of the array. So what this helps in the long run is that the time taken to insert a new element will become O of 1. That's because you have memory blocks already allocated for you and you have to just place the element in that specific memory block. Whereas in case of static arrays, the memory allocated is fixed. If you say you need an array of size 3, provisions it in the beginning, And whenever you try to add any more elements than the three, it will just recreate the entire array. Alright, I have made some space. So let's cover the next topic, which is some of the operations that we can perform on the arrays. The first operation and the most frequently performed one is accessing an element in the array. So once you store something, you would also want to retrieve and use it. So if you want to access a particular element in the array, as we already said, if you know the index of the element, then you can just directly go and access that element. So in case of both static and dynamic arrays, it just takes O of one time. And the next operation is updating. So updating an element is similar to accessing. If you already know the index where you're going to update an element, then you can directly set a different value or a new value in that position. So in both the cases, it's going to take only O of one time. And the next operation is inserting a new element. So updating is just replacing an existing element, but inserting a new element can happen at three different positions. That is, one is at the beginning of the array, then at the middle position of the array, or at the end. When you're trying to insert an element at the beginning, replacing the element at the zeroth position with your new element, which means your existing element at zeroth position needs to be shifted by one place. And the same thing happens to your first position and so on. Finally, your last element is moved to the new memory block. So this happens under the hood, which means it takes O of n times to shift all the n elements. So if you want to insert a new element at the beginning, then it is O of n time complexity for both static and dynamic arrays. And the same thing happens if you want to insert an element in the middle. So say if you want to insert an element at the third index, then all the elements from the third index will be shifted to the next positions, and the new element will be inserted in the third position. So this is also going to take at most of O of n time. And the place where there is a difference between static and dynamic arrays is when we insert at the end, because in case of dynamic arrays, as we saw earlier, the array size keeps doubling whenever we add a new element. So we consider that to be of O of one operation, because in the long run, when the array size is in thousands, you will need to double the size of the array only after performing a series of operations, series of inserts. So we average that to O of 1, and this is called as amortized time complexity. Whereas in case of static arrays, it is still going to take O of n because your array is totally filled up, and so you're going to create a copy and insert the new element. And the next operation is to remove an element. And in case of removing an element, again, it can happen in three places: beginning, middle, and end. And in case of beginning and middle, in both the cases, like static and dynamic arrays, it's going to take O of n time. However, at the end, it is going to take only O of one time. The reason is because, again, if you are removing from the beginning, then all the elements has to be shifted by one place to the left, and the last memory block is deallocated. And the same thing happens for middle. From wherever you're trying to remove, all the memory blocks after that has to be shifted by one place to the left, and the last memory block needs to be deallocated. So in both the cases, it will be O of n. But when you're trying to remove from the end, you can directly remove the element and deallocate that particular memory space. So it's a O of 1 operation in both static as well as dynamic arrays. And the final operation that we are going to look at is copy. And in case of copy, in both the cases, it's a O of n operation because you have to access all the elements in the array and add it to the new location. So it's going to take O of n in both static as well as dynamic arrays. So these are some of the basic operations that you can perform in both static and dynamic arrays. And in most of the recent programming languages, the arrays are by default implemented as dynamic arrays, like in Python, JavaScript. The whenever you declare a list, then it's automatically dynamic. And the best real world examples where you can use static arrays is the places where you already know the size of the array. For example, in case of RGB, storing RGB colors, you already know the list of colors, so you know the memory space required to store all the RGB color combinations. So that can be easily stored in static arrays. When it comes to dynamic arrays, you can prefer them where you don't know the number of items in the list. Like in case of shopping cart, you don't know the exact number of items that can be in a person's cart. So you can use dynamic arrays in such cases. All right, so this was a quick overview on arrays. If you have any questions, please leave them in the comments below. It'll start becoming clearer once we start solving problems. See you soon in the next video. Thank you.